I want to touch on something that the book calls the work energy principle. We've already kind of seen it, but what the work energy principle is it's connecting work to energy. You should already kind of have a feeling for a relationship because they're both measured in joules. All right? So think about where you've already seen this in class. We've already talked about how potential energy is equal to the work to lift an object to the same height. Okay, we did that with our lab and with our practice problems. But there's also, now that we've discussed kinetic energy, there's a relationship between work and kinetic energy as well. So let's talk about that. So say, for example, we have a baseball player, and he's going to throw the ball. It takes work, or a force over a distance, to get that ball to move from his hand, and as he throws his hand forward, it moves a distance, and his arm is applying a force, and then the ball flies away with the velocity. Okay? So if you think about it, what's happening is the baseball player, he's applying a force over a distance, which is equal to some amount of work. Okay? And then when the baseball starts moving, that baseball has a velocity and a mass, so it has KE, or kinetic energy. Okay? So the work required to throw the ball is going to become the ball's kinetic energy. So the work is equal to the kinetic energy the ball has after the work is done. Okay? So just like the work needed to lift an object was equal to the potential energy, the work needed to get the object to that speed for the kinetic energy is equal to that kinetic energy. So maybe you're thinking, well, what if I'm stopping an object, right? And say taking velocity away from it. This is another example of how work and kinetic energy are tied together. So sticking with the baseball theme, say we have, a moving baseball that comes in and you catch it. All right? If you've ever caught a baseball, especially a really fast-flying baseball, usually what happens is your arm has to go backwards a little bit. So your arm is going to experience a force that it applies in order to stop the baseball that happens over a distance, the arm going backwards. All right? But what determines how big that force and distance need to be is the fact that this baseball comes in with a velocity, it comes in with kinetic energy. All right? So over here we have a V and an M. So we have some kinetic energy in the baseball. It's flying at you with some particular velocity. So that kinetic energy has to equal the work required to stop the ball. Okay? So, just kind of we're not going to do any of the practice problem stuff like that right now, but think in terms of how energy is related to work based on the situation. Okay? So the last situation I want you to think about is we have a car, and it's moving at some velocity, and we need to stop the car. Okay? So here's our car moving at a velocity, and then the engine or the brake pedals, they're going to bring the car to a stop. Think about the relationship between the kinetic energy the car has and the work that the brakes need to do in order to stop the car. Okay? So with that thought in mind, kind of think critically about the online form questions, and then we will discuss this and try some sample problems in class tomorrow.